For 12a, question given is fx equal to x squared over x squared plus 1. So the domain is all real number, which is negative infinity to infinity. So since the punya domain is all real number, so no vertical asymptote. So to find the horizontal asymptote, limit x approaches to negative infinity, x squared over x squared plus 1. So we divide with higher degree of denominator, which is x squared. So we simplify, and then we get limit x approaches to negative infinity, 1 over 1 plus 1 over x squared. So we substitute, and then we get 1 over 1 plus 0, then we get 1. So for limit x approaches to positive infinity, x square over x square plus 1. So same step juga, kita divide dengan high degree, which is x square, and then we get limit x approaches to positive infinity, 1 over 1 plus 1 over x square, and then we substitute the positive infinity, we get 1 over 1 plus 0. So we get 1. So therefore y equal to 1 is horizontal asymptote.
Okay. Right.
So question 12b, 2x squared over x plus 4. So we know x plus 4 cannot equals to 0. So x cannot equals to negative 4. So to find vertical asymptote, we need to find limit x approaching negative 4 to the right. So we substitute negative 4 into the equation, and then we got 32 over 0. So 0 is positive value because of when we substitute negative 3 into the equation, we got negative 3 plus 4, which is positive value. So we got positive infinity. Then for limit x approaching negative 4 to the right, to the left, so we substitute the value, and then for this one, 0 is negative because when we substitute negative 5 into the equation, we got negative value. So the answer is negative infinity. So vertical asymptote is x equals to negative 4. And then to find the horizontal asymptote, we use limit x approaching to positive infinity. So we need to divide the equation with the highest degree of the denominator, which is x. So we got 2x over 1 plus 4 over x. So we got 2 times infinity is infinity. So 1 plus 4 over infinity is 1 plus 0. So we got positive infinity. So for limit x approaching to negative infinity, we the same thing. So we just so we got 2x over 1 plus 4 over x, which is negative 2 times negative infinity, we got negative infinity over 1 plus 0, so we got negative infinity. So there's no value, so there's no horizontal asymptote.
Okay.
So for 12c, the question given fx equals to x minus 2 divided by square root x squared plus 4. As you know, the domain is all real numbers, so there is no vertical asymptote. To find the horizontal asymptote, we sub limit x approaching to positive infinity, and then we divide the equation by using the highest degree of the denominator, which is square root x squared. As we know, square root x squared is positive when x is greater than 0, so here is become positive x. So we sub the value positive infinity in this equation, we'll get 1. Same as x approaching to negative infinity, we expand it by divide the x value with the greatest degree in the denominator, and here the x squared square root will become negative x because of the x is less than 0, and then we'll get the final answer in negative 1. So y equals to 1 and y equals to negative 1 are the horizontal asymptote.
Asymptote, the question given fx equals to square root x squared plus 1 over x minus 3. So we can know x minus 3 is not equals to 0, so x is not equals to 3. So we can do this limit x approaching to 3 from the right equals fx. So we can know if we sub the x value here, because x 3 minus 3 is 0. So if we sub 3 value that are bigger than 3. For example, 3.1 will get positive value, so 0 positive, so it's equals to positive infinity. If we start value less than 3, for example 2.9, we'll get negative value, so it's equals to 0 negative, so we'll get negative infinity. So the vertical asymptote is x equals to 3. So we now want to find the horizontal asymptote, which we can use limit x approaching to positive infinity fx. So if we directly sub the value, it will become the indeterminate form. So we can do this. We can factorize square root x squared. So as we can know, because this is positive, so it's x. So it equals to x. Then we divide this by the highest degree of the denominator. So we'll get 1 square root 1 minus 0 over 1 minus 0, so equals to 1. Then for limit x approaching to negative infinity, we can sub this, so it will become to negative x, and divide the highest degree of the denominator. We will get negative 1 times square root 1 plus 0 or 1 minus 0, so it's equals to negative 1. So the horizontal asymptote is y equals to 1 and y equals to negative 1. Thank you.
Okay, question 12e, given fx equals to x minus 2 or x plus 2 squared. So as we know, x plus 2 cannot be equals to 0, so x cannot be equals to negative 2. So for the domain is all real number except negative 2. So to find the vertical asymptote, we do the limit x approaching negative 2 from the right and also from the left. So when we sub negative 2, we'll get negative 4 over 0. Here the 0 is positive because when we use a value greater than negative 2, which is negative 1.9, we'll get a positive value here. So the answer is negative infinity. Same goes to here. When we sub negative 2, we'll get negative 4 over 0. Here is positive because when we use a value less than negative 2, for example negative 2.1, we'll get a positive value here. So the answer is negative infinity. So for the vertical asymptote, it is x equals to negative 2. Then for the horizontal asymptote, we do limit x approaching positive infinity and also limit x approaching negative infinity. When we sub the negative infinity, we'll get infinity over infinity indeterminate form. So we expand first and then we divide the highest power of x, the highest power of denominator to the numerator and also denominator. We divide and get 1 over x minus 2 over x squared over 1 plus 4 over x plus 4 over x squared. So when we divide infinity, we will get 0 minus 0 over 1 plus 0 plus 0, which is equal to 0. Same goes to here. We divide and then when we sub negative infinity, we will also get 0 minus 0 over 1 plus 0 plus 0, which is also equal to 0. So for the horizontal asymptote, it is equals to y equals to 0.
This is question 12f. Given the function is x squared over x squared minus 9, we can factorize the denominator into x minus 3 times with x plus 3. So from here we know the domain is all real number except negative 3 and 3. Okay, and then for the vertical asymptote, we take the negative 3. We take a negative 3 and 3, limit x approaching negative 3 from right and limit x approaching negative 3 from left. So from right, just take back this equation that we factorized earlier and we just substitute a negative 3 into this, and then we get infinity. And then since this is limit x approaching negative 3 from positive, we can take one example such as negative 2.9. We substitute into this. The numerator is square, so we still get positive for this, and then the denominator, we substitute negative 2.9, we get negative and positive. So if negative plus positive, we get negative, so we get negative infinity. And then for the limit x approaching negative 3 from left, same thing, we just substitute a negative 3 and we get infinity. And we take one example from x approaching negative 3 from left, such as negative 3.1, and we substitute into this. The numerator we get positive, the denominator we get negative, and if negative times with negative, we get positive. So the answer is negative infinity. And then for the value 3, limit x approaching 3 from right, we just substitute the 3 into this and we get infinity also. Since this is limit x approaching 3 from right, we take one example such as 3.1 and we substitute into this. The numerator we get positive, the denominator we get positive also. So positive times positive, we get positive infinity. And then for limit x approaching 3 from left, we just substitute, we get infinity also. And x approaching 3 from left, we take one example such as 2.9, we substitute into this. The numerator is still positive and the denominator we get negative and positive. So negative times with positive, we get negative infinity. Since for this vertical asymptote, we get the infinity for this true value, so x equals to -3 and x equals to 3 are vertical asymptotes. And then for horizontal asymptote, we use the limit x approaching positive infinity and limit x approaching negative infinity. If we substitute the infinity into this earlier equation, we get intermediate form. So we divide the new indeterminate form. Okay. And then we get that form, so we have to divide the numerator and the denominator with the highest degree from the denominator, which is x squared. And then we get limit 1/1 minus 9/x squared. And then we just substitute the positive infinity. We get 1/1 minus 0, and we get 1. And then for the limit x approaching negative infinity, we do the same thing also, the dividing the highest degree in denominator, and we get 1/1 minus x over x squared. We substitute the negative infinity, we get 1/1 plus 0, and the answer is 1. Since we get value for the limit x approaching infinity, then the value is the 1 minus 1, y equals to 1 is a horizontal asymptote.
For question 13a, the question given the function is x minus 6 over x plus 1 times x minus 2. So since we know the denominator of this function cannot equal to 0, so the domain for this function is all real number except -1 and 2, or we can write in this form. So for question B, the question wants us to find all the asymptote. So first we find limit x approach -1 from right. So we can substitute -0.9999. So if we substitute into this equation, here we will get a positive 0, and for here negative and negative. So negative over negative is positive, so we get a positive infinity. And for limit x approach -1 from the left side, we substitute -1.001. So also on the numerator we will get a negative value, and for here -1.001 plus 1 is a negative value, and here also a negative value. So negative, positive, and here up is negative, so negative over positive is negative. So for limit x approach 2 from the right side, we can sub 2.001, and so on the numerator we will get a negative value, and for the denominator, here is a positive value and here is a positive value, because 2.001 minus 2 it will be a positive value. So here negative and here is a positive value, so negative or positive value is negative infinity. So for limit x approach 2 from the left side, we can substitute 1.9999. So on the numerator also equal to negative value, and here is a still remain as positive value, but here if negative 1.99 minus 2, it will be a negative value. So negative divide negative, you will get a positive, so positive infinity. So since we get the limit is infinity, positive, negative, infinity, so we can conclude x equals to -1 and 2 is the vertical asymptote for this function.
So to find horizontal asymptote, we start with infinity, but since if we put we start in here, we get indeterminate form. So we divide with the highest degree of x, which is x squared. So we will get 1 over x minus 6 over x squared over 1 minus 1 over x minus 2 over x squared. Then if we sub the infinity, we get since it becomes 0 minus 0 over 1 over minus 0 0, we get the 0. So it's the same thing with the positive infinity. We divide with the highest degree of x first, then we sub the x and it becomes 0. So we can conclude that y equal to 0 is the horizontal asymptote. So for the question C, we need to sketch the graph. So as you all know, x equal to negative 1, 2 is vertical asymptote, and y equal to 0 is the horizontal asymptote. So we plot the graph first. So this is the line for the asymptote, 81 and 2. And so to sketch the graph, we put here point this one, then this two, and then this two. So we sketch it. So since this touch the y-axis, so as you all know, if anything touch the y-axis, s equal to 0. So we sub into this equation with 0, s with 0. So fx will equal to 3. So we put 3 is the crossover of the y-axis.
For the question 14, given gx equal to 3x over x squared minus 4, so we know that x squared minus 4 is much greater than or equal to 0. And also, this cert must not equal to, this denominator is not equal to 0. And when we combine these two equations, we get x squared minus 4 is greater than 0. And from this, we find the value of the x, and the x is equal to negative 2 and positive 2. And we sketch the quadratic graph, and we get the domain from negative infinite to negative 2. Unit between 2 to infinity, and when x equal to negative 2, it approaching from the left to the right, and we can substitute the value of negative 2 into this x, and we get this one we get 0 is positive value, and when we divide we get negative infinity. For the x equal to 2, if approaching from right to the left, and we substitute the value of 2, and we get 6 over 0 positive value, and we get positive infinity. So we can conclude that x equal to negative 2 and x equal to 2 are the vertical asymptote of G. And for the question C,
for question C, the question wants us to find the limit of x approach infinity for gx. So it is also equals to the limit of x approach into positive infinity of 3x over square root x squared minus 4. So first of all, if we directly substitute positive infinity, it will become the indeterminate form, which is infinity over infinity. So we need to divide by the highest degree of the denominator, which is x. So we divide each term by x, and this one, as we know, square root x squared also equals to x. So after that, we simplify the equation. We get 3 over square root 1 minus 4 over x squared, and then we substitute x approach to positive infinity and get equals to 3. Same for the limit x approach negative infinity. If we directly substitute negative infinity, we will get indeterminate form. So we need to divide by the highest degree of the denominator, which is x. So after that, this one we divide by negative square root x squared, because the x is the negative value. It approach negative infinity. So after that, we just simplify, and we substitute x approach negative infinity, and then we get it is equals to negative 3. So in the end, we can conclude that y equals to 3 and y equals to negative 3 are the horizontal asymptote of G. That's all.
thank you. Thank you.